Okay, so here's stage 3 of solving simultaneous equations. Now this time we need to multiply one of our equations first because we don't already have the same quantity of either x or y. Now first things first, as always, I like to first of all label my equations in case I need to refer to them. So there's equation 1 and there is equation 2. Now I have 4x in this one, but only 1 there. I've got 3y in the first one, but only 1y in the second. Now, I could multiply my second equation by 4 to make x's the same, or I could multiply it by 3 to make the y's the same. I have decided to make the y's the same. Actually, you could do either. You'll get the same result at the end, but I've just decided to change the second equation to make the y's the same. So I'm going to times it by 3. And that just means you times absolutely everything in your equation by 3. Because if we think about this, if I have 3 times as many x's, 3 times as many y's, I'm going to have an answer that is 3 times as big. So 3 times x is 3x. And 3 times the y is 3y. And 3 times 7 is 21. Now it's important to keep labeling your equations in case you need to refer to them. So this is now equation 3. Now I have the same quantity of y's, so according to my flowchart that I like to use, I can now go ahead and eliminate one of my variables. I can turn that variable into nothing. And it's the y's that are the same, and they're both positive, which means it's not my special case. I don't need to add them together. Because they're both positive, I am going to take one equation away from the other. And I always like to take the small one away from the large one. So the large equation really is equation 1 because it's got the most amounts in it, the largest amounts. And I'm going to take away equation 3 from it. So a bit more on familiar ground now. We've done this a few times before. We know the drill. We've got 4x, take away 3x in this case, because I'm doing equation 1, take away equation 3. And that will leave just a single x. I've got 3y, take away 3y, which leaves nothing. And I've got 23, take away 21, which is 2. I'm just going to neaten this up a little bit, bring it closer together. X has the value of 2 in this case. And as before, I can now substitute that back into one of my equations. I'm going to use red just to kind of highlight the difference here. You could use either. Well, in fact, you can use any one of the 3 and they will all work. They'll be absolutely fine. You'll get the same answer. But just choose the one that you think is simplest. And for me, I think that's x plus y equals 7. Now, I know x has got the value of 2, so I'm going to put 2 instead of x. And the rest of my equation is plus y equals 7. So 2 plus something equals 7. I think we can see without doing too much effort that y must be equal to 5. 2 plus 5 is 7. So there's my solution for this pair of equations. X is equal to 2 and y is equal to 5. And let's just pause a moment to think about what a solution is. A solution means if I change in either of my equations at the start, if I change the x for 2 and the y for 5, I will get these two answers. This is the only solution when both these equations are correct for the same values. Right, let's try another example. So let's first of all get rid of the writing and rid of the equation. Let's have a new equation or pair of equations, which are here. And I've got 4x plus 2y equals 25, and 3x plus 3y is 19.5. Now, neither of these has the same quantity of either x's or y's. And I can't easily change one of my equations into having the same quantity as the other equation. I suppose I could times my first equation by 1.5, but that's a bit fiddly, so I'm not going to do that. I'm going to label up my equations first of all, because that's the first thing I like to do, so I can refer to them. And I am going to aim to make the y's the same. Now, I could make the x's the same. And I'd be looking for the lowest common multiple, so the first multiple I could get to. So in this case, it would be 12 for the 4 and 3. So I could change them both to have 12x, but I'm actually going to change the y's to be the same. Again, any method or either of those methods would get us to the same answer at the end. I'm going to go for the lowest common multiple of 2 and 3, and so I'm aiming to have 6y in both equations. Let's put a little line in to separate off our answers. And first things first, let's take equation 1, and I'm going to need to times it by 3 to make 6y. So 3 lots of 4x will be 12x, and 3 lots of 2y makes 6y, and 3 lots of 25 makes 75. And keep labeling equations as we make new ones. So that is equation 3. Now equation 2, I also want to have 6y, and I need to double that to get the same amount of y's. So I need to do equation 2 times by 2. Now 2 lots of 3x makes 6x. 2 lots of 3y will make 6y, and it's plus in there. And 2 lots of 19.5 will make 39. 39. And label it equation 4. And again, we're back on familiar ground here. We have got 2 equations that have the same quantity of y's. And let's have a look. They're both positive, so it's not my special case. Remember, if the signs are opposite, for whatever variable you're using, we're using y, and the variable is both positive. If it was opposite, I'd need to add them. That's my special case. But this isn't. This is they're just both positive, so I need to take one equation away from the other. And I always like to do the big equation, which in this case is 3, take away the smaller equation, which in this case is equation 4. Right, so back on familiar ground, 12x take away 6x leaves 6x. 6y take away 6y leaves nothing, and that's what I was aiming to do. Put in my equal sign. 75 take away 39 leaves 36. Let's neaten that up. 6x equals 36. And now I can probably guess actually what x is going to be, but I'm going to do this the official way. I'm going to divide both sides by 6 because I don't want 6x, I want 1x. So 6x divided by 6 will leave just x, and 36 divided by 6 leaves 6. Well done on your times tables. So x is worth 6. Okay, usual drill, back onto my flowchart, and it says once I know one variable, the value of x in this case, I need to substitute it back into my equation to find the value of y. Now I can use, in this case, any one of my 4 equations. They're all simultaneous, they will all work. Just find the one that you think is easiest. So in this case, for no real reason, because they're all pretty much the same, I am going to choose to use equation 1. So I'm going to swap x for its value, which is now 6. And so I have got 4 times by the 6, because it's 4x, and I've got 2y, so I add the 2y, and 25. That is just equation 1 with x swapped for 6 for its value. Well, 4 times 6 is 24, plus the 2y apparently equals 25. It's not completely obvious at this point what the value of y is going to be, so let's keep going with the official route. Let's take away the 24 from both sides, because we don't need the 24. Remember, I want the y's on one side, I want the numbers on the other. So 24 take away 24 leaves nothing, so that's disappeared. And 2y equals 25 take away 24, which is 1. So 2y is equal to 1. In that case, I can see from that y must be worth a half. And I could put a half as a fraction or 0.5. Either is absolutely fine. So my final solution to these pair of equations is x equals 6 when y equals a half. And let's just remind ourselves at this point what this means. This means that if, for my 2 equations at the start, if I substitute into both of them x equals 6 and y equals a half, I will get these 2 answers. Basically, these 2 equations are true at the same time for this pair of values. And that is the only time that these 2 equations will be correct at the same time for the same values.